Okay, so today we will have solving quadratic equation by extracting square root. So I have here the steps in solving quadratic equation by extracting square root. So given an example, y squared is equal to 9. The first thing first is you are going to isolate the quadratic term. So you've noticed that on the left side, we only have here y squared, which is the quadratic term. So it is already isolated. So proceed to the next step. Get the square root both sides of the equation. So you are going to extract the square root of y squared and also the square root of 9. Now, getting the square root of y squared, the result is y. Take note, getting the square root of e power 2 here, the answer is we have only y. So what is the square root of 9? We have positive and negative 3. So don't forget the sign, the plus and minus 3. Every time that you are going to get the square root on the right side here. So, therefore, the values of y is positive 3 and negative 3. Now, to check if our answer is correct, so we just simply substitute the value of 3. So, if y squared is equal to 9, so that it becomes 3 squared. What is 3 squared is equal to 9 is equal to 9. So, therefore, y sub 1 is equal to 3 is a root. Now, if you have a negative 3, still substitute it to the value of y, negative 3 squared. Squaring negative 3, that results to a positive 9. So 9 is equal to 9. So therefore, the values of y sub 1 is 3 and y sub 2 is equal to negative 3. So we can also say that the roots of the quadratic equation y squared is equal to 9 is positive 3 and a negative 3. Next example, x squared minus 121 is equal to 0. First is isolate the quadratic term, which is x squared. So since we have here negative 21, so you are going to transpose negative 121 to the left or the right side to isolate x squared. So that becomes x squared is equal to positive 121. So you are going to change the sign from a negative to a positive. The next step is you are going to extract the square root both sides of the equation. So the square root of x squared and the square root of 121. What is the square root of x squared? That is x. And the square root of 121 is positive 11 and negative 11. Again, don't forget the plus and minus sign. So to check whether our answer is correct, so substitute 11. So that becomes 11 squared is equal to 121 minus 121 is equal to 0. For negative 11 squared, that is 121 still, is minus 121 is equal to 0. Don't forget that if you are going to check, use the original equation. So therefore, the roots of the quadratic equation x squared minus 121 are positive 11 and negative 11. Now, the next example is negative 144 plus r squared is equal to 0. Still isolate the quadratic term r squared. So you are going to transpose negative 144 on the right side. Change the sign to negative from negative to positive. So then next, get the square root both sides. So the square root of r squared is r. The square root of 144 is positive 12 and negative 12. To check, substitute the value of r. So if r is equal to 12, 12 squared is 144. Plus a negative 144 is equal to 0. So r sub 2 is negative 12. Negative 12 squared is 144. Plus negative 144, that is 0, is equal to 0. So therefore, the roots of the quadratic equations are positive 12 and negative 12. Next example, we have 2x squared minus 32 is equal to 0. So first thing first, isolate the quadratic term. So that becomes 2x squared, transpose negative 32 to the right side. So change the sign, so that becomes positive 32. Now, you've noticed that we have here a positive 2. Supposedly that we have to change this into 1. So take note, we have here 2. So divide both sides by 2 first before getting the square root. So if you are going to divide by 2, that becomes x squared is equal to 16. 32 divided by 2 is 16. That's the time that we are going to get the square root both sides of the equation. So the square root of x squared is x. The square root of 16 is positive and negative 4. Again, the sign of 4 is positive and negative 4. So therefore, the roots of the equation is positive 4 and a negative 4. To check whether our answer is correct, so we are going to substitute the value of x. So we have, if x sub 1 is 4, Get the square of 4 first, that is 16, times 2 is 32, minus 32 is equal to 0. The same also with x sub 2 is equal to negative 4. That is negative 4 squared is 16 times 2 is 32. That is 32. So, by the way, this is 32 instead of 121. That is 32. So therefore, uh, this is an example of a solving quadratic equation by extracting square root. Let's have another example of solving quadratic equation by extracting square root. So if we have 2x squared minus 16 is equal to 0, first thing first, you are going to isolate the quadratic term. So since negative 16 is written on the left side, so you are going to transpose on the right side. So that becomes 2x squared is equal to 16. So you are going to change the sign negative 16 to positive 1. Positive 16. Then, since we have here 2 as the coefficient, so you are going to divide it by 2 first. So divide it by 2, so x squared. 16 divided by 2 is 8. Then that's the time that we are going to get the square root of the both sides of the equation. So the square root of x squared is x. And square root of 8, since 8 is not a perfect square, so we don't need to write it in decimal form. So instead, you are going to factor 8 such that one factor is a perfect square. So the factor of 8 is square root of 4 times square root of 2, since 4 is a perfect square. So what is the square root of 4? That is positive and negative 2. Take note of the sign. And just copy square root of 2. So therefore, the values of x, so we have 2 square root of 2 and a negative 2 square root of 2. Now to check, to substitute the value of 2 and square root of 2 to the original equation. So instead of 2x squared, that becomes 2 times the square of 2 square root of 2 minus 16. What is the square of 2 square root of 2? That is 4 square root of 4. 2 times 2 is 4. 2 times 2 is 4. What is square root of 4? That is 2 times 4 is equal to 8. Times 2 is equal to 16. Minus 16 is equal to 0. So therefore, 2 square root of 2 is a root of the given equation. Now, a negative 2 square root of 2, substitute it to the value of x. So that becomes 2 square of negative 2 square root of 2 minus 16. What is the square of negative 2 square root of 2? That becomes negative 2 times negative 2 is positive 4. 2 times 2 is 4. Square root of 4 is 2. Times 4 is 8. Times 2 is 16. Minus 16 is equal to 0 is equal to 0. Therefore, 2 square root of 2 and negative 2 square root of 2 is a root of the given equation. 2x squared minus 16 is equal to 0. Let us have another example. We have here 2x squared plus 32 is equal to 0. Isolate the quadratic term. So you are going to transpose positive 32 to the right side. That becomes negative 32. Then divide both sides by a positive 2. So 2x squared divided by 2 is x squared. Negative 32 divided by 2 is negative 16. Get the square root both sides of the equation now. Getting the square root of x squared. Now you've noticed that we have here a radicand of negative 16. So if you are going to get the square root of a negative number, the result is not a real number. So there is no real roots on the given equation. Take note, if there is a negative term or negative number inside the square root sign. So this is an example of a quadratic equation having two complex roots. So there is no real roots of this given equation. So just leave it, since we don't have the topic yet on complex fraction, but this can be a complex number. But this can be simplified using a complex uh, terms or complex number. So just state it, no real roots. Now, another example, the square of the quantity y plus 3 minus 25 is equal to 0. So isolate the quadratic term. This time, the quadratic term here is the square of y plus 3. So since it is already, we are going to transpose 25 on the right side. So that is 25, positive 25. Get the square root both sides. So getting the square root of the square of y plus 3, the result is y plus 3. Then the square root of 25, we have positive and negative 5. Take note, positive and negative 5. So to simplify, y plus 3 is equal to 5. and y plus 3 is equal to negative 5. Since on the right side, we have a positive and a negative 5. Solving for the value of y, transpose 3. 5 minus 3 is 2. So the first value of y is 2. To solve for y here, transpose 3 on the right side. That becomes negative 3. Negative 5, negative 3 is negative 8. So therefore, the values of y is 2 and a negative 8. So to check whether our answer is correct, so we have the original equation, the square of y plus 3 minus 25 is equal to 0. Substitute y by 2. 2 plus 3 is 5. Getting the square of 5 is 25. Minus 25 is equal to 0 is equal to 0. Now, if we have our negative 8, a negative 8 plus 3 is negative 5. Get the square of negative 5, still that is 25. Minus 25 is equal to 0. So therefore, the roots of the equations are 2 and a negative 8. Now, another example, y squared minus 4 over 49 is equal to 0. Isolate y squared. So, transpose negative 4 over 49 on the right side. That becomes positive 4 over 49. Extract the square root both sides. So, the square root of y squared is y. The square root of 4 over 49, that is 2 over 7. Positive and a negative 2 over 7. So, to check whether our answer is correct, so substitute 2 over 7 on the first y squared. So y, that becomes 2 over 7 squared, that is 4 over 49. Minus 4 over 49 is equal to 0 is equal to 0. Now, if we have here a negative 2 over 7, getting the square of this, still that is positive 4 over 49 minus 4 over 49 is equal to 0 is equal to 0. Therefore, the roots of the equation is 2 over 7 and negative 2.
I never